Ladies and gentlemen, we are finishing up 9.4? 9.5. Wow, I'm further along than I thought. We are still talking about combinations. A yearbook editor has selected 14 photos. That's going to be important. We know there's going to be 14 photos, so N is equal to 14, including one of you and one of your friend, to use in a collage for the yearbook. The photos are placed at random. There is room for 2 photos at the top of the page. What is the probability that your photo and your friend's photo are in the 2 placed at the top of the page? So we're going to be using 2 of these photos, and because it tells us this twice. We're going to be using 2 of those photos. That's our R. And we have 14 possibility of photos to be chosen from. That's our N. So our combinations are 14. So I'm just going to put that everywhere that's here. Put that minus there. And then we have 2 choices. So when I work through and I simplify this, by the way, we're only finding the total combinations. This is not actually answering the question, what is the probability? We're setting up to find that. Right now, I need to know how many total choices there are, and then I have to take the favorable outcome and divide it by the total number of outcomes possible. That's what we're figuring here, is how many total outcomes are possible. All right, so 12 minus 2 is going to be equal to 10 factorial times 2 factorial, all under 14 factorial. And I already have it worked out because 14 factorial is the same as 14 times 13 times 12 factorial. Oh, wow, I messed that up. All right, this should have been 14. I apparently did the math in my head and wrote the number, and I hope I said the right number. At least I would have had that. So this is 12, and that's why I stopped at 12 here, because the 12 here existed. I also have 2 times 1. So what I can do at this step is I can realize, again, anything divided by itself is 1. And this 2 can go into 14 7 times. So it's completely done. So I have 7 times 13, which is what I got here. I'm not going to completely box it in. I meant to actually... Ooh. That's what I wanted to tap. I meant to actually be here. I can jump ahead, or I could have just left it as 14 times 13 over 2. Then I could have done my canceling here. The canceling or simplifying can happen at any stage. I like the idea of doing it a little bit early and combining all my simplifying into one step, because that means I don't have to write this step in between. But when I take 7 times 13, I get 91. What that means is I have 91 total options. But there's only one favorable outcome. That is, my friend and I are chosen as the first 2 photos. Now, I'm going to, oh, sorry. So the order doesn't matter. Just want to be able to, when they choose the first photo, it's whether it's me or my friend doesn't matter. When they choose the second photo, whether it's me or my friend doesn't matter. That's why order doesn't matter as long as we're on the same page. That's what we're looking for. That's why this is a combination instead of a permutation. So there's one favorable outcome, because whether they choose me or my friend and me, it's the same. So that means I have a 1 in 91 chance, little over a 1% chance for my friend and I to be randomly chosen to be on the same page together in our collage for our yearbook.